We will start the characteristics of wave. But let me give a quick review about the yesterday topic. All right, how can we define wave? So I'm repeating, wave is made up of periodic motion. Periodic motion means any motion which is repeated at regular interval, that is defined as periodic motion. All right, and wave is a disturbance that transfer energy from one place to another place. So it means that the students, when a wave is generated, so it means that the medium is not transferred, only the energy is transferred in terms of wave from one place to another place. All right. Now you can see, students, there are two types of waves. Number one is called transverse wave and number two is called longitudinal wave. So what are transverse waves? Transverse waves are those waves in which direction of propagation of wave and vibration of particle, they are perpendicular to each other. Such type of waves are called transverse waves. All right. And in transverse wave examples are light waves, electromagnetic waves, water waves. All right. And S waves. Not S waves, sorry, P waves. P waves are transverse wave. And the next one is longitudinal waves. Longitudinal waves are those waves in which vibration of particle and direction of propagation of waves are parallel to each other. So such waves are longitudinal, which requires medium to travel. And the example of longitudinal waves are sound waves. Okay, they travel in form of compression and rarefaction. All right, and transverse wave travel in terms of crust and trough. Okay, so yesterday I started the topic characteristics of waves. Okay, that is very, very important. Characteristics of waves. So I told you there are five characteristics like amplitude, wavelength, frequency, time period, and wave velocity. So I discussed the initial two characteristics in the yesterday class. All right, amplitude. So what is the definition of amplitude, students? Amplitude means height of wave or energy in a wave, that is defined as amplitude. So you can, well done Hafsa. So you can see beta, this is the wave. So one positive cycle and one negative cycle will make one cycle of wave. Okay. So now you can see beta, this line is representing the reference line and the height of this wave is called amplitude. Okay. This is the amplitude. Amplitude is a height. So its unit can be meter or it can be centimeter. We will use the symbol capital A to represent the amplitude. All right. So whenever, if the examiner will give you the wave like this, so first of all, you have to draw the reference line. Like first we will draw the reference line like this. Then you can mark any of the peak, like you can mark the trough or you can mark the crest as well. Both are representing the amplitude. Okay. Then I discuss the next thing, that wavelength. How can we define wavelength? Wavelength, I told you, the horizontal distance of one cycle is called wavelength. I'm repeating, students, horizontal distance of one cycle is called wavelength. Then other definition I told you, the distance between one crust to another crust is defined as wavelength, or the distance between one trough to another trough. So if I ask you to mark the wavelength, so you can see the cycle is starting from this position and ending at this position. So this one is called wavelength, and wavelength symbol is lambda. Wavelength symbol is lambda. All right, this is the lambda. It's a Greek letter that is defined as wavelength. So now you can see this is the crust and this one is also crust. So wavelength is the gap or horizontal distance between the mid of one crust to the mid of other crust. Similarly, beta, wavelength is defined as the gap between one trough to another trough. So basically all these three distances will be same and it is defined as wavelength. Are you understanding this thing, students? Wavelength is a distance, so it can be measured in meter or centimeter, and its symbol is lambda. Lambda is a Greek letter, beta. Its symbol is lambda. Okay. All right. Then the next thing is frequency. All right. Write the heading frequency, beta. Frequency definition is important for the theory paper as well. So number of cycles passing through a fixed point per second is called frequency. per second is called frequency. Alright, number of cycle passing through a fixed point per second is called frequency. So frequency means in 1 second how many number of cycles are generated, that is defined as frequency. Alright, like for example, if I draw a wave here, this is a reference line. Alright, and now this one is representing crust, trough, crust, trough, crust, trough. So basically in 1 second there are 3 cycles. Alright, there are 3 cycles. So it means its frequency is 3 cycles per second. But if I draw the another wave here, this is another wave. Alright. And if I draw one more wave here, so there is only one cycle which is making one crust and one trough. So it means that there is only one cycle per second. So it means that the first wave has greater frequency and the second wave has less frequency. Alright. So frequency means if there are more number of cycle in 1 second is defined as frequency. So greater number of cycle means greater frequency. Alright. Alright students, and frequency symbol is F. Alright, we will use the small f. Alright, and its unit is hertz. Hertz is a scientist name. Alright, you can use the symbol capital H and small z. Hertz is a unit of frequency which is equals to second inverse. All these are the units of frequency. Hertz, Hz is a symbol of hertz, and second inverse. Second inverse is also a unit of frequency. Are you understanding this thing, students? All right. So it means beta frequency is defined as number of cycles generated in 1 second is defined as frequency. All right. Okay. Now I'm going to clear the screen, students. Right. Next heading, time period. What are they? Time period. Time period is the time required to form one wave or one cycle. 1 minute. Is the time required to form one cycle is called time period. It is the time required to form one cycle is called time period. Alright, time period and frequency are inversely proportional. Time period and frequency are inversely proportional to each other. I'm repeating, students. Time period and frequency are inversely proportional. How? Let me show you. I'm drawing two different waves. This is the first wave, its reference line. All right. And you can see there is only one wave. So it means there is only one wave. So its frequency is less, but its time period is greater because it will take long time to form one cycle. All right. But if I draw the another wave, like this one is a reference line. Okay, if I draw the other wave, so 1, 2, 3, 4. So there are 4 cycles. So I told you that what is the definition of time period, beta? Time period is a time required to form one cycle. So this is the time period. Not we will not take the all cycles time period. Obviously, time required to form one cycle is defined as the time period. So one cycle time period here is very short as compared to the first wave. So it means that if the time period is smaller, frequency is larger because you can see there are more number of cycles. So it means we can study a relation between the time period and frequency that they are inversely proportional to each other. So now I can write the formula here, F is equals to 1 upon T. Like if I'm able to find the time period of a single wave, so I can calculate the frequency by using this formula. All right, everyone. So please write down this formula, students. Frequency is equals to 1 upon T. All right. They are inversely proportional to each other. If the time period is greater, like in the first wave, frequency will be smaller. Or if the time period is small, frequency will be larger. Clear, students? Have you noted down each and everything? So I can move towards the next thing. Okay, now good. Well done. So let me clear the screen. I'm moving towards the next characteristic, that is wave velocity. All right. Wave velocity. How can we define the wave velocity? It's a simple speed of the wave. Wave velocity means speed of the wave, which is equals to speed is equals to distance upon time. Okay, what is the formula of speed, students? It is equals to distance upon time. So distance in terms of wave is the horizontal distance of one cycle, which is defined as wavelength. So basically I can replace the distance with the letter lambda. So now student, the formula will become lambda upon t. And we know that the students frequency is equals to 1 upon t. So now I can replace the time period with the frequency. Like if I rewrite this formula, so how will I rewrite, students? Velocity is equals to lambda multiplied by 1 upon t. They both are same thing. Velocity is equals to lambda multiplied by 1 upon t. And 1 upon t is equals to frequency. So it means that v is equals to f lambda. So this is a very famous and very important equation of this chapter. In terms of wave velocity, velocity of wave is equals to frequency multiplied by wavelength. So if we are able to find the frequency and wavelength, so we can easily calculate the wave velocity. All right, students, please note down. Note it down, students. V is equals to f lambda. V is the speed of a wave. Done? Okay. All right. Now, students, I'm going to clear the screen. I have added some past paper questions here, so we are able to solve these past papers to understand this topic fully. Okay. Now, question number 10. Now, student, this is your turn. What is the frequency of a wave? What is the frequency of wave? Yes, students, in option A, they are saying the number of wave passing a fixed point per second. In option B, they are saying the number of peaks added to the number of trough, the time taken for one wave to pass a fixed point. In option D, the time taken for the displace. So, Inaya and Zurez are saying C is the right answer. Hafsa is saying B. What about other students? Which one is the correct answer? Everyone is saying C, but I told you the definition of frequency, that number of cycles passing through a fixed point in 1 second is defined as frequency. Alright, I'm repeating beta. Number of cycles or number of waves passing through a fixed point in 1 second is defined as frequency. A is the correct answer. Exactly, students. A is the correct answer, that number of waves passing a fixed point in 1 second is defined as frequency. Alright, A is the correct answer. Clear, students? Is it clear to you? Alright. Now I'm moving. Yeah, exactly, beta. B is not a correct answer. I didn't discuss about the number of peaks. I didn't discuss about the number of peaks. Alright. I told you the number of waves which are passing through a fixed point in 1 second, that is defined as frequency. Alright. Now I'm moving towards the next question. You can see the question number 42. In question number 42, they are saying the diagram shows the variation of the displacement of a wave with distance from the source. So now you can see on the x-axis, they have given us distance in centimeter, and on y-axis, they have given us the displacement in centimeter. Well done, everyone. Well done, Ahmed, Hafsa, Zain. So now they are asking what is the amplitude of the wave. So what is the amplitude, beta? Amplitude is the height of wave. Amplitude is the height of wave. So you can see I told you this is the height of wave, which is 2 centimeters. So it means A is the correct answer. Well done, everyone. Manahil, Inaya. Well done, students. A is the correct answer. All right. Now, next question. In the next question, they are saying question number 39. You can see in question number 39, they are saying that diagram shows a graph of wave motion. This is a displacement versus time graph. Acha, one thing which I want to tell you, beta, that if on x-axis time is given, so we are able to calculate the time period. We cannot measure the wavelength because time, obviously time will give us the time period of one cycle. If the distance is given on x-axis, then we are able to calculate the wavelength. All right. So in this equation, Q is basically representing the time period, not a wavelength. Okay, students, Q is representing the time period because they have given us the time on x-axis. So how we can measure the wavelength? Obviously, we cannot measure it. All right, so Q is basically the time period. So answer can be A or answer can be C. And P, there is displacement on y-axis. So displacement will give us the amplitude. All right, so P is representing the amplitude. So A is the correct answer. All right. Is it clear to you, everyone? A is the right answer. Okay. So remember this thing, student, if the time period is given on the x-axis, so we are able to find the time. If the distance is given, so we are able to calculate the displacement or wavelength. Okay. Now, this equation I have already discussed with you that V is equals to F lambda. So lambda is equals to V upon F. V is the velocity and F is the frequency. Okay. And what should be the unit of speed? What should be the unit of speed? Speed symbol is V. I'm asking about the unit of speed. Meter per second. Exactly. Students, meter per second. Speed unit is meter per second. Okay. Now, moving towards the next question, question number 34. In question number 34, again, you can see the time is given on the x-axis and displacement is given on the y-axis. Okay. Now, they are asking to calculate the frequency. So, frequency can be calculated by using the simple formula 1 upon T. Okay. So, it means students, yes, Hafsa, if we know the time period, so we can easily find the frequency. And you can see we are given time period on the x-axis and time period is the time of one cycle. So, this is one cycle. So the one cycle time period is 2 seconds. One cycle time period is 2 seconds. So frequency is equals to 1 upon 2. Frequency is equals to 0.5 hertz. Hertz is the unit of frequency. Alright. So now you can see students B is the correct answer. Is it clear to you? Alright. Now I am moving towards the next question. The next question is from the theory paper. In this question, they are saying, Isa, you are not participating today, Ayan. In question number 4, they are saying figure 4.1 represent a wave on the surface of water. So you can see on the surface of water, transverse waves are formed. On x-axis, time is given. On y-axis, displacement is given. Now they are asking determine the amplitude of the wave. Well done, Inaya. So amplitude means height of wave. Height of wave. You can measure any height, beta. So now it is basically lying in between 10 and 20. So the height of wave is 15 centimeter. Well done, everyone. Well done, Zen, Zurays, everyone. All right. So height of wave is 15 centimeter. Okay. Now in the next part, they are asking determine the frequency of the wave. So frequency we can easily find by using the formula 1 upon T. Okay. So if I am able to calculate the time period, so it means I can find the frequency. All right. So how we will calculate the frequency? You can see the wave is starting from this point. ending at this point. So this is the one cycle. It is one cycle. So it's a time period of one cycle. So if this one is 1.5 because it is lying between 1 and 2, 1.5 second. And this one is 3.5 seconds. So time period will be 3.5 minus 1.5. What we will get, students? 3.5 minus 1.5. I want to know the time period. 2 seconds. Exactly. The time period is 2 seconds. Okay? The time period is 2 seconds. Alright. So frequency is equals to 1 upon 2. So frequency is equals to 0.5 hertz. Alright. Acha, what the student usually do mistake in this type of question? What they did do? They take this cycle. Which one is incorrect? Because we have to take the complete cycle. Complete means from where the wave is starting and the point at which the wave is ending. Okay, that is the one cycle of time period. Did you understand this question, everyone? Ayan, Ahmed? All right. Okay, good. Now I have added some more past paper questions here. In this question number 7, you can see transverse wave is given. Water waves are transverse wave, obviously, and they have shown a different symbol like P, Q, R, S, T. Now they are asking, state the letter which represents the amplitude of the wave. So amplitude means height of the wave. Height of the wave is called amplitude. Okay? So which one is the right answer, students? I'm waiting for everyone. Why you people are not replying me? Well done. S is the correct answer. Well done, Zen. Well done, Inaya, Ayan, Hafsa. Okay, so basically this height. So I told you we can take the crust height or we can take the trough height. Both are representing the amplitude of wave. So we must write S here. All right. Now in the next part, they are asking wavelength of the wave. So wavelength is the horizontal distance of one cycle, or wavelength is the horizontal distance between one crust to another crust and one trough to another trough. So here you can see from one midpoint of one crust to the midpoint of the other crust, it is representing wavelength. So Q is the correct answer. Excellent. All right. Now in the B part, they are saying the water molecules move at right angle to the direction of travel of the wave. Obviously, now they are saying state the name of this type of wave. Well done. Well done, Zen. So, well done, Hafsa. These are transverse waves. Well done, Ayan. Excellent. These are transverse waves. All right. Transverse waves are those waves in which vibration of particles and direction of propagation of wave are perpendicular to each other. Ahmad, are you understanding? All right, in the C part, they are saying state the meaning of the frequency of a wave. So, frequency means you have to write the definition of frequency here. Number of cycles passing through a fixed point in 1 second is defined as frequency. All right. Number of waves, number of cycle passing through a fixed point in 1 second is defined as frequency. Clear, students? All right. Now I'm going to clear the screen. I hope you all have noted down. Okay. Now I'm moving towards the next question. Okay. Now you can see question number 8. These are again transverse wave because they are water waves. Okay. Now they are saying use the information in figure 7.1. Determine the wavelength of the wave. Wavelength of the wave. So now you can see beta, wavelength is the horizontal distance of one cycle. So you can see on x-axis they have given us the distance. So you can see the wave is starting from this point and ending at this point. So one crust and one trough will together make one wavelength. So it is starting from 4 centimeter, ending at 12 centimeter. So 12 minus 4, it will give us 8 centimeter. So it means the student's wavelength of a wave is 8 centimeter. Alright. Now they are asking in the next part to determine the amplitude of the wave. So amplitude means height of the wave is called amplitude. Okay. And you can see this height is lying in the middle of 1 and 2. This one. So it means it must be 1.5 centimeter. Okay. 1.5 centimeter is called amplitude of the wave. Is it clear to you? All right. Now I'm moving towards the next question. We have completed this part and you can see most of the questions are related to the characteristics of wave. Oh, 1 minute. Now in the next question number 10, figure shows a part of a water wave. State the letter P, Q, R, S or T on figure 6.1 that represent the wavelength of the water wave. So we have to find the wavelength here. Assalamu alaikum Ishal. Ishal, you are 30 minutes late today in class. We have discussed so many topics and past paper questions. So student, what is the right answer? Which letter is representing the wavelength? Yes, Ishal, why you are late, beta? Okay, letter R. Exactly, student. Letter R is the horizontal distance of one crust to another crust. So letter R is representing the wavelength. Excellent. Now in the next part, they are saying state the letters that represent the amplitude of the wave. So it's a very easy question, beta. Amplitude means height of wave. So which letter is representing amplitude? Yes, students, well done. P is representing the amplitude of the wave because amplitude means the height of the wave. Height of the wave is called amplitude. Now you can see in the third part, they are asking the definition of frequency. So it means the student frequency definition is very important because in every part they are asking about the frequency definition, that is number of cycles passing through a fixed point is called frequency. Exactly, Hafsa. Alright, students. Now the last part is remaining, that is question number 12. In question number 12, they are asking a wave of frequency 13,000 hertz. So you can see, student, they have given us the frequency, that is 13,000 hertz. It is traveling a distance is given 1300 meter. This is not wavelength, beta. Basically, they are giving us the distance which the wave is traveling in a particular time, that is 4 seconds. Now they are asking to calculate the wavelength of the wave. So we have to calculate the wavelength. All right. So how we will calculate the wavelength, students? Do you have any idea? How we will calculate the wavelength? Which formula we have to use here? Assalamu alaikum, Amna. So we will use the formula V is equals to F lambda. Exactly, students, we will use the formula V is equals to F lambda to calculate the wavelength. So Amna, you are taking the first class today. So let me tell you, we are discussing the chapter wave. Okay. And we are solving the past paper questions of topic related to waves. Now students, we are using this formula V is equals to F lambda. So basically lambda is the wavelength. So we have to find lambda. So we will make it independent. So lambda is equals to V upon F. So F is already given in the question, that is equals to 13,000 hertz. Now we have to find, we don't have speed here. So can we calculate speed, students? How can we calculate the speed? We will use the formula speed is equals to distance upon time, as I told you in previous slides. So speed is equals to distance is 1300 and time is 4 seconds. So 1300 divided by 4. What we will get, everyone? 325 meter per second is the speed of this wave. Alright. Now we can easily find the wavelength by using this formula. Lambda is equals to V upon F. V is equals to 325. Frequency is equals to 13,000. Now divide both of them and tell me what wavelength we are getting here. Yes, students, what wavelength we are getting here? A. All right. Hafsa is saying we are getting 0.025 meter. Ishal, can you tell me what answer you are getting? What answer we are getting, Ishal? Aiza? Okay, well done. A is the right answer. So basically, well done, Manahil. So you can see, student, we can do the use the multiple formulas in a single question. Like first, we have found the speed. Then I use this formula lambda is equals to V upon F to calculate the wavelength. All right. Please note down this calculation. Then we will start the next topic, that is triple tank. Okay. Okay. Have you noted down this calculation, students? Can I clear the screen? All right. Now, students, we have done the enough practice of past paper questions of this topic, that is characteristics of wave. Now, I'm moving towards the next topic, that is ripple tank. This topic is newly added in your syllabus and this topic is very, very important. All right. देखिए बेटा, in the starting of this chapter, I told you we can generate the wave with three different instruments. Do you remember, student? Let me show you the first slide. I told you in the first slide that wave can be produced by rope, by ripple tank or by slinky spring. So I told you we can generate the longitudinal wave with the help of slinky spring. We can generate the transverse wave with the help of the rope. Now students, we are going to study the third instrument, that is ripple tank. Ripple tank is an instrument which is used to generate different types of water waves. Alright. This topic is very, very important, beta. So ripple tank is an instrument which is used to demonstrate the basic properties of wave. All right. So this instrument, you can see this is the instrument. It is a simple glass tray which is filled with water. All right. And you can see there is a screen below this simple glass tray. All right. And there is a motor. This motor is connected with a pulley and this pulley is connected with a wooden plank. This plank is called flat dipper. Okay, because it is dipped into the water, that's why it is called flat dipper. And this pulley and motor is connected with the power supply. There is an illuminating light bulb which is showering the light on this water, so we can form the image of the water waves which are formed in this glass tank. So basically what is happening here, when we will turn on the power supply, so this pulley will move the dipper up and down. Do you remember, students? Yesterday I shown you multiple simulation. Yesterday I shown you this simulation in which we are generating the water waves by moving the water. You can see here, this is the side view. So you can see the water waves are moving up and down. So it means that the particles are vibrating up and down and the wave is traveling towards the right direction. So ripple tank work on the same phenomena. Okay. So let me show you again my slides. So basically what this dipper is doing, it is moving up and down. So when it will move up and down, so it will generate the transverse waves, and these transverse wave will move from left side to the right side, and we can see the image of the transverse wave below this glass tray. Are you understanding the construction of the ripple tank, students? I have the simulation of ripple tank as well. Let me show you 1 minute. I have the simulation as well. There is one more simulation website, ophysics.com. So we can see the simulation here. Uh, I don't exactly remember that where we can generate. No, just give me 1 minute, students. Let me find where we can observe the simulation of ripple tank. Yeah, this one. All right. So you can see, beta, this is the same ripple tank which I have shown you in the diagram. All right. Just I want to show the one wave. Okay. So you can see this is a spherical dipper. There are two types of dipper in the ripple tank, flat dipper and spherical dipper. So when this dipper is just moving up and down. Okay. This dipper is just moving up and down. So it is generating the water waves, and these waves are traveling from one place to the another place, and its image can be observed below this ripple tank. All right, you can see the side view how this dipper is moving up and down. So because of this movement it is generating the transverse waves. You can see the top view as well, that how the water waves are generated. All right, students. So if I will increase the frequency, so this dipper will move rapidly. You can see it is moving with the fastest speed, so it is generating more number of cycles. And if I will decrease the frequency, so it means beta it will move slowly and it will generate less number of cycles. Are you understanding this thing, students? So this one is the ripple tank, beta. Acha, what is the purpose of using ripple tank? Ripple tank is basically used to study the different characteristics of waves. Like we can study the different phenomena like reflection, refraction, and diffraction of water waves with the help of the ripple tank. All right. So now you can see, students, this is the flat dipper. This dipper will move up and down. So when this dipper will move up and down, the water molecules in the ripple tank will start to move up and down, due to which transverse waves are generated. You can see these are the transverse wave. This one is representing crust, trough, crust, trough. So water waves are moving towards the right side. So we can analyze the wavelength, we can find the wave speed, or we can find the time period of the water waves. Basically, ripple tank is a simulation of any actual waves. It's a simulator basically. So we can study the earthquake waves as well. We can study the tsunami waves as well, with the high frequency tsunami waves with the help of the ripple tank. All right, it's a type of simulator which we can use to study the different properties of wave. Is it clear to you, everyone? All right. Now you can see how the ripple tank is generating the water waves. These blue balls are representing the surface of water molecules, and this is the dipper. All right. So when the dipper will move down, so the water molecules will absorb energy and they will transfer the energy to the neighbor water molecules. All right. Then when the dipper is moving upward, so it means that the water molecules will also move upward and they are still transferring energy to the neighbor particle. So similarly, beta, by moving the dipper up and down, the water molecules are also vibrating on their mean position and they are transferring energy to the